Hi students, let's look at this question here, which is on Trigo. Let's say, okay, do this proficiently. So prove the identity. Obviously, we're going to start from the hard part, which is the more complicated part, the one on the left, right? Proving. So this case here, I'm going to start from left hand side. Then this is cosine theta, 1 minus sine theta, plus 1 minus sine theta over cosine theta. Now the key thing here is that this on the right is actually 1 over cosine theta times 2. Okay, so it's 2 cosine theta. So we make it a common, what do you call it, a common denominator, a single fraction. So what I'll do is, for the denominator, I will leave the cosine theta outside. Please don't expand. Okay, the idea is if you expand, you're gonna get very it's gonna be very complicated very quickly. So because we need the 1 over cosine theta on the right. So this case there, once done, this is cosine square theta. Then this will be 1 minus 2 sine square theta plus sine square theta. 1 minus sine theta. This is cosine theta. Once done, cosine square theta, sine square theta, that will be our, this both is actually just 1. So 1 plus 1 minus 2 sine theta. This will become this. So this will be 1 minus sine theta and cosine theta here. Okay, so once this is done, this is 2 minus 2 sine theta. There you go. Can you see that because of this, I could just retain this. This 2, bring it up to 1 minus sine theta. 1 minus sine theta is cosine theta. Then cancel these 2 out. And I will get 2 cosine theta. This is 2 secant theta, right hand side. Okay, so that's how you do this question here proficiently. So let's look at the second part, which is to solve a trigo equation. Okay, second part is essentially, there will be, even if you can't do the first part, you can actually just do the second part, right? So this case here, you could see that actually you substitute theta as 3b, 3 beta. So this case here, for part 2, on the left hand side, cosine 3 beta 1 minus sine 3 beta plus 1 minus sine 3 beta cosine 3 beta is equals to 4. So you know that beta is equals to 3 beta is equals to theta. Alright. Correct. So theta is equal to 3 beta. So essentially this will be the one on the right, the row on the left hand side would just be 2 secant 3 beta equals to 4. So secant 3 beta is equals to 2. Okay, then cosine 3 beta will be reciprocal to, okay, so you could just see this as 1 over cosine 3 beta equals to 2, then you take the reciprocal. It works. So now this is interesting. So once this is done, this is actually, take note of the basic angle and so on. Look at the range. The range is from beta 180, then you just multiply by 3, 0, and this is 3 beta, and then after which this will be 180 times 3 will be 540 degrees. Okay, now your basic angle, always start with basic angle, alpha, is cosine inverse half. Okay, this is a special angle that will be 60 degrees. Okay, so we know that 3 beta is either in, cosine is positive either in Q1, Q2, Q4. Okay, cosine is positive. So just write down all the possible angles. So Q1, Q4 will be 360 minus 60, which is 3 degrees, right? So this case here, alright, this is Q4. This is Q1. Okay, now look at 3 beta. You need all the angles from 0 to 540. So what you need to do is actually just plus 360 and see whether any of these angle fall within the range. So this will be 420, I believe, and this will be 660. So you obviously reject this because 3 beta is 0 to 540. This 660 is not considered. So it's essentially this, or this. So 3 beta is given by 60, 300 degrees and 420 degrees. So we divide by 3 throughout. 20 degrees, this will be 100 degrees. 420 divide, this will be 140. Okay, so that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.